Okay, I'm going to show you how to do the things that you're going to need to for your assignment today. So we're going to look at scatter plots, which is just a bunch of ordered pairs that are plotted, that somebody's collected some data. And so you could have three different situations. You could have some scatter plots that look kind of like this, and we say that that would have a positive correlation because the points are kind of going like that. They don't make a perfect line, but we could draw a line through them and that would have a positive slope. So we say that that has a positive correlation, which means as x increases, y also increases. You could have something like this that would have a negative correlation. So we could draw a line through there that would have a negative slope. So we would say it has a negative correlation, which means as x increases, y decreases. Or you could have something like this where you can't draw a line through it. It's just scattered everywhere. And so you would say that there is no correlation. One doesn't really predict the other one, okay? So you might have a situation like this, a question like this, where it'll ask you if it has a positive or negative correlation and to fill in a sentence or to write a sentence about it. So it's kind of grouped together, but basically we could kind of draw a line through there. You know, if we kind of circled our points, it would make a line that direction. So this has a positive correlation. So we would say positive, and you can just abbreviate it like that. And then we're going to write a sentence. Now they've already started this sentence for us. As the height of the football player increases, because that's the x-axis, the weight usually increases. Okay, so that's how you would do something like that. Okay, so if you had one like this, it would say, you know, what is the correlation? Well, this is definitely going downhill. So that means there would be a negative correlation. Actually, they want us to put it in there. So a negative correlation. As time increases, the number of landlines generally decreases. Okay, so that's how you would do that. So then they're going to ask you to actually make an equation like we've been doing. So here they've worked it out. So we're just going to go through the steps of what they've done. So here's the correlation. Here's our line that goes through it. And so if they told you to write a line that uses this point and this point, then this is what you would do. They're just doing it for you to show you how to do it. So you would find the slope. Okay, so 32,752 minus 25,108, and then on the bottom 10 minus 5. So that number is 7,644. 10 minus 5 is 5. Divide it out. You're going to get decimals on these. Go ahead and divide it out with your calculator and see what you get. So we're going to round that to the nearest tenth, and then that's your m. So we're going to use the same things that we've been doing. So in this case, they chose to use this first point. So y minus 25,108 is equal to the m that they found in the last step times x minus 5. So that's what we've been doing. But you're going to have to take a calculator to multiply this out. So when you take 1,528.8 times 5, you get that. Add that over and you get that. So that would be your equation. So it's the same as we've been doing, it's just working with bigger numbers and decimals. Okay, so let's look at this one and here at the bottom. Okay, so it has ordered pairs. They've plotted the ordered pairs. We've got a nice correlation going here. It says use the data points 10, 20, and 50, 80 to write an equation. So they did not give us enough room for this. So if I were to do that, first we would have to find our slope. So that's going to be 80 minus 20 over 50 minus 10. So 80 minus 20 is 60. 50 minus 10 is 40. So then you could get your decimal. You could reduce that to 3/2, but go ahead, since we're working with decimals today, go ahead and divide it out. You're going to get 1.5. So that's our m. So then choose one of the points. So if I choose to use 10, 20, and m is 1.5, then I'm going to have y minus 20 is equal to m times x minus x1, which is 10. So y minus 20 is 1.5x minus 15, because I got to take 1.5 times 10, and then I'm going to add 20 to both sides. So y equals 1.5x plus 5. That would be my line of best fit. Okay? So that would be this answer. Y is equal to 1.5x plus 5. Then it says use the equation to predict the amount of milk needed for a 17-pound goat and a 55-pound goat. So the weight is your x's and the milk needed is your y's. So this is our x equals 17. So we have an equation here that says y is equal to 1.5 times x, and we're going to use x equals 17 plus 5. Then you're going to take your calculator and you're going to do 1.5 times 17, which is 25.5. And then you're going to add 5 to that, so that's going to be 30.5. So that's how many ounces of milk you would need, 30.5. Okay, to do 55, that's our x equals, like we got y for our ounces, so x equals 55. So we're going to use our equation. Y is equal to 1.5 times 55 plus 5. So take your calculator. 1.5 times 55 is 82.5, plus 5 more is 87.5. So that's how many ounces of milk it would need, 87.5 ounces. Okay, so your worksheet is pretty much just like that. You should get along fine.